Okay, students, I shall start off with the class. Uh, I'll start off with the screen sharing. Can you see my screen, guys? Yes. Okay. Okay, fine. Okay, so previously we discussed on compression types. Remember? So today we'll discuss about the other type. That is, we have two types of compression, right? Remember? That is, 1 sec. Okay, so remember we have two types of compression. One is lossy compression, the other is lossless compression, right? So lossy compression we already know. That is, it means there is no loss of information, right? And that is, we can't exactly say no loss of information, but what happens in lossless compression is that the original data, it can be recovered exactly from the compressed data. That is about lossless compression. And lossless compression, it has its use in a wide variety of fields, and the most important field is it is used in text compression, right? You remember, I hope. So in text compression we use lossless compression, and then we did not discuss about lossy compression, right? In lossless compression we discussed about types also, but in lossy compression, so today we'll go through lossy compression. Okay, we just have to know what is lossy compression. It has some types, but we only have to focus on the main concept of lossy compression. Okay, so lossy compression, unlike lossless compression, what happens is that in lossy compression, when you do compression, that is when you follow this type of compression, some of the data from the original file is lost. And here, when I'm talking about file, I'm talking about an image format file. Okay, and here suppose JPEG. So when you're trying to compress a JPEG image using lossy compression, what happens is that some of the data from the original file is lost. Okay, and unlike lossless compression, the process is irreversible. That is, once you convert the file into lossy, or once you convert the original file into to lossy, you can't go back. Okay, that is already it is lost, and the process is irreversible. Okay, and what happens is when you try to compress the image more, the more degradation occurs. That is, more you compress the image, more degradation occurs. That is, degradation means the quality of the image, it keeps on degrading. Okay, that is, quality of the image, it keeps on losing the quality of the image. So when we talk about image formats, mainly lossy compression focuses on JPEG and GIF. Okay, so these both are lossy image formats. So then, one of the biggest obvious benefits to use lossy compression is that it results in a significantly reduced file size. Okay, fine. We can use lossy compression to compress a file from say 8 MB to 8 KB. Okay, but it also means there is quality loss. Okay, it also means there is quality loss, and also we use a lot of plugins, we can use a lot of tools, we can use a lot of software, but that is, it will let you choose the degree of compression you want to use. That is, when you want to use lossy compression, you can also use some plugins, tools and software. You can get it online, but thing is that however much you use this, you'll definitely get a compressed image, but the image will be distorted. That is, you'll get a degraded image. Anyhow, lossy compression, the name itself says that some of the data from the original file is lost while you perform compression using lossy. So when you keep on using lossy compression for compressing the image more and more, it keeps on degrading more and more. Okay, so say in the example here, you can see that an image was taken and different compression ratios were applied to it. Okay, so different compression ratios, say this is the original JPG, that is, this is a JPG image. Okay, so this is a JPG format image. So when you try to compress it using lossy compression, say this, you try to compress it by 50%, so this is 76 kb, and then again you try to compress it using by 80%, and this is 34 kb. So this is not visible to the naked eye. Okay, but you can say that the quality has hampered. Okay, but if you look at it closely, in the dark gray areas on the middle and far right images, it is very noticeable where compression artifacts begin to occur. That is, when you are using this type of compression in these two, that is, we have already used lossy compression, that is, this second image has compressed by 50% and the third image has compressed by 80%, right? So compression artifacts begin to occur, that is, some slight changes it tends to occur, but it's not visible directly, but actually it is occurring. Okay, so with lossy compression, it is about finding a medium ground which you are happy with for file size and still retaining an acceptable image quality. That is, whatever be it, if you use lossy compression, then you are able to compress the file as much as you want. Definitely there will be a limit, but that is also a considerable limit. Okay, so say with 50% compression applied, we decreased our file image by 90%. With 80% compression applied, we decreased our image file size by 95%. So here it is saying that you used lossy compression technique in this original image and you tried to compress it by 50% and 80%, and result is 76 kb and 38 kb images. Okay, but lossy also has its own advantages, its own disadvantages. So one important advantage is that, or one very interesting you can say, is very small file sizes and lots of tools, plugins and software supported. That is, with lossy compression comes a lot of tools, plugins and software. That is, it supports these things, but in lossless it doesn't support. Okay, and disadvantage is quality degrades with higher ratio of compression. That is, however higher ratio of compression you apply to an image, the quality keeps on degrading and you can't get the original file back after compression. Okay, so you can so depending on the situation, depending on the image, you can apply lossless as well as lossy compression. Okay, so lossless compression also has its own advantages and disadvantages, and that also applies to lossy compression. Okay, so if you can remember one type of compression, then you'll be able to write the other type. Okay, uh, just draw two columns and write, in one you write lossy, in the other you write lossless, then you compare these. Okay, so when you compare, you'll like all the points will be, it will be clear then. So this is about lossy compression. Okay, then we were discussing on I think image segmentation. Yes, so image segmentation, do you remember what is image segmentation? Why we use image segmentation for an image? Yes, do you remember? Anyone? Hmm? What is segmentation? What is segmenting? We are talking about segmentation of an image, right? So image segmentation is nothing but you are segmenting or dividing the image into some parts. Yes, division of image. Yes, and we are dividing the image in order to like group the parts. That is, when you are segmenting the image into parts, you are just not segmenting it like that. Okay, you are trying to segment the image and then you are trying to collaborate those parts only which has common features, right? Say one part has features common with color, Another part has features common with, say, some other features, say. So we have a lot of features, right? So depending on those features, you can group those parts, and then finally again you collaborate it. So why we perform segmentation on the images, that we want to clearly picturize the features. That is, uh, we want to check the quality as well as the particular features. And then after extracting the features, that is, after we know that these are the features, and after that we can again finally collaborate the parts, and then we per- and then we get the output image. So image segmentation is nothing but you are trying to segment the images into parts after trying to extract the features, after getting to know all the features, and again you collaborate it and you get the output image. Okay, so this is a part, that is segmentation. It refers to the process of partitioning a digital image. We are talking about digital image into some multiple regions, and those multiple regions are nothing but these are some set of pixels. Okay, and goal of segmentation, we know that is, it is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. Definitely we try to represent the image into something which has more meaning, and then meaning in the sense we are trying to extract the features, right? And it's easier to analyze also. That is, if you segment the parts into, that is, if you segment the digital image into multiple regions, and and then again you can try to check the features, right? So also it's easier to analyze in that way, because then we get to know, this part has this feature, this part has this feature. Yes. So image segmentation, where it is used is, it's used to locate objects and boundaries in an image. That is, when we talk about image segmentation, we talk about a very important part, that is the edge detection. Okay, so edge detection, so this is one form of revision. Okay, this is one form of revision. So I'm taking up image segmentation again, and again we'll go on to edge detection. Okay, then each of the pixels in a region are similar with respect to some characteristic. That is, it may be color, it may be intensity, it may be textures. These three are very important features of an image. Okay, and adjacent regions are significantly different with respect to same characteristic. Adjacent regions means like besides, that is adjacent, that is close to each other. Okay, and some applications of image segmentation, that is, image segmentation is mainly used in medical field. Okay, say example, to locate tumors and other pathologies, then to measure tissue volumes, then in computer guided surgery. And these are the examples of these three fields. Okay, then we spoke on that, we know what is image segmentation. We have different definitions for image segmentation. That is, you can say it reduces pixel data to region based information, or you can say it classifies pixels into objects or groups, or you can also say form of segmenting the foreground from the background. And in simplest case, it is saying that it is trying to take out the thresholding value. That is, it thresholds grayscale pixel values. So I hope you remember what is a grayscale pixel value. Do you remember what is a grayscale pixel value? Or do you remember what is a grayscale value? Hmm? 0 to 255. Okay, fine. Okay, so you remember what is grayscale pixel value, right? See, we will come across these concepts again and again, but still I'll keep on asking again and again, because I know you people keep on forgetting again and again. Okay, and what is thresholding? What is thresholding? Why do we use thresholding for an image? Hmm? In simplest form, in simplest definition, what do you understand by thresholding? Hmm? No one? Conversion. Okay, conversion of image. And is there any limit for that? Hmm? RGB to gray. Okay, that is, you are trying to partition the image into foreground and background, right? Yes. So we can say that, yes. So we can say that we are partitioning an image from foreground to background. That is, you are also transforming a colored image to grayscale, and you can also use the function that is RGB to gray, right? So this is image segmentation. This is about thresholding, right? That is, we have an upper limit, we have a lower limit, right? Then comes edge detection, which is a very important part in image segmentation. Okay, that is, when you are segmenting an image, you are actually talking about the boundaries and the edges in the image, right? So what we understand by images, in edges in images are areas with strong intensity contrast. That is a jump in intensity from one pixel to the next. That is, when we say edge detection or when we say edge of an image, it means that it is the boundary of an image. So when you see the boundary of an image, we actually analyze an image firstly by looking at the edge of the image, that is the boundary, right? So when we can analyze the boundary of the image, we can actually sense that this is this image, right? Or this is this object, right? So edge detection is nothing but it is talking about detection of edges in images with areas of strong intensity contrast. And strong intensity contrast you already know. Yes, intensity means what? Brightness. Contrast stretching, actually it is talking about a concept, contrast stretching. Okay, so when you talk about one concept, it regards many concepts. Okay, it comes five six concepts comes into being. Okay, so when you're talking about edges, that is detection of edges, it is talking about intensity contrasts, that is contrast stretching, if you can remember that concept. Okay, then edge detecting an image significantly reduces amount of data and filters out the useless information while preserving the most structural properties in an image. That is, when we talk about edge detection, one most, or not most, the most important feature, you can say the most important feature of edge detection of image is that it tries to reduce the amount of the data which is useless, and it only keeps those data which is important, that is important in the sense which is having important structural properties in an image. That is, structural properties means what? That which is able to define an image or an object properly. Okay, and then when we talk about properties, we use two types. That is, there are actually many ways to perform edge detection, but we mostly talk about two types. One is the gradient and one is the Laplacian. So gradient method you already know now. Do you remember what is gradient or slope of an image? Yes, slope, that is m equals to del y by del x, remember? Yes, that is this gradient method. It detects the edges by looking for maximum and minimum in the first derivative of an image. And then we use Laplacian, that is Laplacian method. It searches the zero crossings in the second derivative of the image to find edges. That is, we talk about the derivatives, that is first derivative and second derivative. We don't have to solve actually, but we have equations. Okay, we have equations to clearly understand what is gradient and what is Laplacian. Okay, I'll show you the equations, that is not needed now. Then we go on to determining intensity value for threshold. So already you know what is intensity value for threshold. That is, we talk about some upper limit and we talk about lower limit. That is, thresholdings, it separates the foreground pixels from the background pixels, and it can be performed before or after applying a morphological operation to an image. So morphological operation, do you know what is a morphological operation? Morphological operation means do you remember what is morphological operation? What is it related to? When we talk about morphology, we are referring to, yes, it is based on shape, right? That is, we are talking about the structure of an object. So morphology, it is also a very important part in image segmentation. That is, it is overall important in image processing, and Mainly it is important in image segmentation, because in image segmentation we talk about the edges, and edges is nothing but it is the shape, right? So in morphological operation, what happens? Each pixel in the image, it is adjusted based on value of other pixels in its neighborhood, right? So thresholding, it separates foreground pixels from the background pixels, and it can be performed before or after applying a morphological operation to an image. And with a threshold operation produces a binary image. So binary image, we know it is in the form of zeros and ones, right? And it relies upon the definition of an intensity value. Okay, so with each pixel we have an intensity value attached with it. So intensity value is compared to each pixel value within image, and output pixel is generated based upon conditions stated within the threshold. Definitely. Yes. Then we spoke about what is a proper histogram and what is a bad histogram, right? So that is intensity. Histogram, it is based on intensity, right? That is contrast stretching. So intensity histograms provide a means of determining useful intensity values as well as determining whether or not an image is a good candidate for thresholding or stretching, that is contrast stretching. So here it is comparing two histograms, that is, this is a good candidate, this is a poor candidate. And good candidate in the sense that this is, you can what is a histogram? Histogram means you can tell the quality of an image by simply looking at the histogram of an image, right? So here this is considered as a good image because this uh, you know this whatever the graph is, it is clearly visible, that is, it is able to clearly depict the it is clearly depicting, say, the intensity of an image. So whatever intensity is taking some example, and here it is not able to relate it because it is just flowing, the curve is just flowing. Okay, so they are comparing intensity histogram, and this is based on segmentation. Okay, and then we have region growing. That is, region growing is a part of image segmentation where pixels or a group of pixels, or say sub-regions, uh, these are grouped into some larger regions when homogeneity criterion is satisfied. Homogeneity criterion is that, remember, if the features are the same, then it is considered in a part. Again, if some other feature is same for some pixels, then those pixels are again considered in the other part. So this is homogeneity criterion. So region grows around the seed point based on similar properties. Seed point is nothing but it is talking about this seed pixel, that is the root. And properties, it is talking about gray level, then texture and color. Okay, when we are talking about image segmentation and its properties, so when asked about the properties in any part of image segmentation, the properties are nothing but it talks about gray level, texture, color, and some similar properties. Okay, then pros and cons we have, it is better in noisy image where edges are hard to identify. That is, region growing is used in images, that is noisy images where the edges are hard to identify. So mainly what we are trying to do is we are trying to detect edges in an image, right? And when the edges, it is uniform, and suppose you are able to quickly identify the edge of an image, then then it is said that the image is of good quality, right? So region growing is used in better used in noisy image where edges are hard to identify. And cons is seed point must be specified first, that is the root must be specified first, and but different seed points will give different results. That is it depends on the viewer. Okay, so these are some pros and cons in region growing. You just have to remember that region growing is a part of image segmentation where pixels are grouped from into larger regions where homogeneity criterion is satisfied, and homogeneity criterion is satisfied with properties which are gray level, texture, and color. Okay, and it talks about some seed point, that is, it's talk about the pixel, that is the root pixel. Then we have region oriented segmentation. So region oriented, that is region growing, that is region oriented segmentation. We talk about two types, one is region splitting and one is region merging. So region splitting, you already have got an idea by looking at the by looking at these two words, right? That is region splitting. So region splitting means region growing starts from a set of seed points, and an alternative is to start with the whole image as a single region and then subdivide the regions that do not specify a condition of homogeneity. Okay, that is region oriented segmentation. So this is a type of segmentation which is talking about some region in an image. And region oriented segmentation is again divided into two parts. One is region splitting and the other is region merging. So region splitting, it starts from some set of seed points, that is seed pixels. And alternative is to start with the whole image, that is, suppose it is taking the whole image as a single region. Okay, suppose this is an image and they are taking this whole image as a single region, and after that they start dividing the regions which do not satisfy a condition of homogeneity. Okay, we'll see to that again. Then region merging means it is just the opposite of region splitting. That is, we are splitting the image if the conditions do not apply. But region merging is just the opposite of region splitting. That is, it starts with small regions and it merges the regions that have similar characteristics. Okay, that is, region splitting means what? If the regions are not satisfying it doesn't have similar characteristics, then it is splitted. But if those regions, again, it is satisfying the condition of homogeneity, then it is merged. That is, it is merged means it is clubbed together into one part, that is, into one region. Okay, and similar characteristic, it is about texture, color, and gray level, and again they are talking about variance also. Okay, and typically splitting and merging approaches are used iteratively. Then we have split and merge approach. So first they are talking about region splitting. So region splitting also, it is divided into two types. One is top down and one is bottom up. So top down means it splits the image into homogeneous quadrant regions. That is, suppose this is a region. So quadrant means 4 parts. Okay, and again you can see here this is a sub part. Okay, this they are talking about that is region splitting and region merging. These approaches are used iteratively. So here they talk about region splitting, where we use two types. One is top down, one is bottom up. And top down means splitting image into homogeneous quadrant regions, that is, it is divided into 4 parts. And bottom up means it merges similar adjacent regions. That is, first what happens in top down procedure, it splits the image into 4 parts, into 4 homogeneous quadrant regions. 4 homogeneous quadrant regions means those regions have similar properties. And bottom up means it merges similar adjacent regions. Again, when it finds some similar regions, but only when it is adjacent, it merges those regions. Okay, and the algorithm, it includes top down and bottom up. That is, top down means successively dividing the region into quadrant regions, that is R. Okay, and it stops when all the regions are homogeneous. That is, the idea behind this is that first they divide the region into 4 quadrants. That quadrant means 4. It divides the region into 4 parts, that is, into quadrants, and then it keeps on dividing it. It keeps on merging it accordingly. That is, after dividing the region into 4 parts, it merges similar adjacent regions, and then it keeps on following the same step until and unless it won't stop until and unless it gets all the regions to be homogeneous. Okay, this is an algorithm. I'll show you again. So this is just the definition, that is the basic concept of region splitting. It is using 2 parts, that is top down and bottom up. And in bottom up, it happens is at each level merge adjacent regions. That is, some levels will be there, and in each level the adjacent regions are merged. Not just merged, it will check if it is homogeneous, that is, it has the same properties or not, and then only if it is adjacent, it is merged. Okay, then we have, so this is an example of region splitting, that is, it is using region splitting algorithm. And then finally this is the output. This is original, this is after split, and this is the actual output. Okay, so region merging and region splitting, these are algorithms. You just have to understand the algorithm. I don't think problems are there for these. If yes, then actually you'll have to solve it in MATLAB. Okay, I'll check to these. Let's see. Mm, then this is split and merge algorithm. Okay, so suppose this is a sample image. Okay, this is a sample image. So you can see what is it speaking about. It says that you have to use the top down. Suppose you are using the top down approach, split image into homogeneous quadrant regions, and homogeneous quadrant regions means 4 parts. So same sample image, it is divided into 4 parts, and this they are naming it as the first split. Okay, then again this is dividing it into the second split. How it is dividing? See, this is the main image. First you divide it into 4 parts. Now we have 4 part means we have 4 regions, right? So this is talking about the first split. In second split, what you can see is again these 4 parts, again these are subdivided into quadrants. That is, suppose this was the first region, right? So this is the first region in the first split. So in the second split, this first region again is divided into quadrants, that is 4 parts. So see, it is divided again. And then here in third split, what it is doing, so this is actually an algorithm. So I'll show you again. So this is dividing it into again splits. Again, see how in the third split it is splitting. It is trying to split in adjacent way. These are, so till here, till second split it is easy, right? But in the third split, what it is doing, see, it is splitting it. It is splitting it so minutely. That is, it is first trying to check if the properties are homogeneous or not, and accordingly it is splitting it here. So you don't have to do anything, you just have to apply this algorithm. You have to use a sample image, and the MATLAB will simply use the algorithm and it will split the image in this way. But yes, the MATLAB code you have to give it correctly, right? Then what happens after the third split? That is, it is splitting in such a way that the homogeneous parts are together. Okay, so it will be different for different images. So these are pixels. Okay, these are pixels. So it is dividing it in such a way that the homogeneous parts are together, and then finally it is merging it. Okay, there is no fourth split. You can have fourth split, fifth split. This is still third split. So maybe in the third split they are able to find all the homogeneous properties. So what it is saying, that it stops when all the regions are homogeneous. That is, when it has found that all the regions are homogeneous, then it has stopped. So maybe in the third split it has found all the homogeneous regions, so it has stopped. Now it has merged again accordingly, and this is the final result. Okay, we'll have to see this again. So it's not complicated, it's not at all complicated, but you see, you have to keep it step by step. That is, first is top down, then is bottom up, and then finally you are splitting it, and then you are merging it, and this is the final result. Okay, I'll show this to you again. We have the second type, that is, it's not here. We have region merging also. Okay, region merging, they are showing it here itself. That is, they are using it iteratively they are using it. That is, this is split and merge, they are using it together. Okay, so finally they are merging it, and this is the final result. Okay, so I'll show you this with another example. Okay, this is just an image. I'll show you with pixels the next time. Okay, so just remember this procedure. That is, this is the algorithm. That is the split and merge, that is region split and merge approach. It both the approaches, they use top down and bottom up. That is 2 types, and accordingly it performs segmentation. So finally we are talking about segmentation of an image, right? So segmentation happens with the help of region splitting and region merging. So this is this example only. I'll show you again with a proper example. Okay, so let's end it here for today. We have another class now, that is, we have CNS, right? So take 5 minutes break, or okay, take 10 minutes break. We'll start off again at 3:10. Okay, kindly come back at 3:10. So were all of you present? how many of you are absent today? I think 2 of you are absent. No, 3 of you are absent. Anyway, just come back at 3:10, okay? We'll start off with CNS again.
Okay, ma'am.
Okay.
Thank you.